Good morning, good afternoon, and good evening. This is Mrs. Radel with another Algebra 2 video. We're learning about exponential functions and how to write equations to model these exponential functions. So we're going to start with another example. At the start of an experiment, there were 6 bacteria on a plate. Every hour, each bacteria splits into 3 bacteria. How many bacteria will there be in 4 hours? And then how many bacteria will there be in 12 hours? So when we are writing an exponential functions equation, we need three pieces of information. We need the initial value, we need the factor, and we need a unit of time. So in this case, the initial value is going to be represented by this C value. And it's how much do we have at the start of the experiment. At the start of the experiment, there are 6 bacteria on the plate. So the initial value is 6. And then we also need this factor. How much are we multiplying by every time? So let's start to fill out this table and see the pattern. So at hour 0, there are 6 bacteria. And at hour 1, each of these bacteria are going to split into 3 bacteria. So we have 1 bacteria, and it's going to change into 3 bacteria. So if this happens 6 times, it's like multiplying by 3, which means that we will have 18 bacteria in the next hour. And then in the following hour, we're going to multiply by 3 again. So in that next hour, we're going to have 54 bacteria. And so what we're multiplying by every time is 3. Because we're changing from 1 bacteria to 3 bacteria. And then what does the X represent? The X represents the hours. So because it says every hour, this population triples. So the number of hours. Okay, so now we can just plug in this information into our general formula. F of X equals the initial value, which is 6, times the factor of 3 raised to X, which is our number of hours. So now if we want to find how many bacteria we have after 4 hours, we can just plug in 4 wherever we see an X, because the X represents hours. So instead of doing F of X, we're going to do F of 4. Okay? So wherever I see an X, I'm going to put a 4. 6 times 3 raised to the 4. And that gives me 486. Okay? And then if we want to do the same thing with 12 hours, we're just going to plug it in. So whenever you see the X, we're not going to put 4 anymore, we're going to put 12. Okay? So if you plug that into your calculator, 6 times 3 raised to the 12 is a very big number. It is 3,188,646 bacteria. So you can see that when the bacteria's population is tripling every hour, it really gets out of control very quickly. And so there are 2 different ways that we could get these values. We can plug it in with 4 as the input and 12 as the input, but once they start to ask us about more than 2 values of X, it might be better to make a table. So you can always just go into your graph, in your graphing calculator, plug in this function right here, exactly how you see it, and just pull up a table by Control T, and it will also give us these values. So at 0, it's 6, at 1, it's 18, 2 is 54, 3 is 162, 4 is 486, and 12 is that big value of 3,188,646. So go ahead and look over this example and the example from the last lesson when we were talking about the rabbits, and then go ahead and go on to eDoctrina and start to answer these first few questions. So the questions are right here. So what it wants you to do is look at the scenario and write an equation that models it. So go ahead and go on eDoctrina and try these first 6 equations. And then there's this bonus example that you can start thinking about how you would answer this question, and then we'll go into more detail about this question in a few lessons from now. So go ahead and give it a try. If you have any questions, please let us know on Schoology. Thank you.